Hey guys, this is Rahul here. Welcome to the session, guys, and I hope you are doing good. So, today we are going to talk about Python for data science. Some cool stuff which Python helps us to do that, right? And this is one of the best programming skill which we have for data science point of view. We can achieve a lot of things using Python. So, we'll talk about each and every aspect of Python in detail. So what is the agenda for today? The agenda for today is need of data science. Why people are really require data science? People are talking about data science of the future and a lot of things. So why it is and why suddenly companies are looking for data science professionals? So first of all, the agenda is need of data science. What is data science? How Python is used for data science, data manipulation in Python. Then we are going to talk about implement machine learning using Python, and we'll have some demos. We'll try to solve one of the classification problem using Python. So now what is the need of data science? Suddenly there is a vast expansion of the data happened. People are saying that data is the fuel of 21st century and we can do a lot of stuff using data. But if we think about, let's say 10 years back, we can say that data was there at that point in time as well. But why data science, machine learning, artificial intelligence, these things not there at that point in time? The only reason is that we had very less processing power machines, and also the storing capacity was very less. If you guys remember, uh, we had like when I got my first machine, it was like 512 MB RAM machine, and I used to save my school projects, college projects in the floppy drive, right, which was like 64 MB or something. I'm not sure, like very small, 258, 256 MB or something. So when the pen drive thing comes into picture at that point in time, it was costing around 2000, 3000 rupees for 64 GB pen drive. And now if I talk about 1 terabyte of hard disk, it is costing around 2 3,000 rupees. So suddenly there is an exponential reduction in the cost happened, not only in the saving the data but at the same time processing power as well. These days we are getting mobile phones of 4 GB RAM and so on. My machine, this machine is 16 GB RAM machine, and people are talking about 32 GB RAM, 64 GB RAM, and so on. So the processing power increased drastically, and because of that, the data capturing is very much faster, and also we can company has a lot of flexibility to store the various different data sources. At the same time, if I want to process that data, that will be very fast for us as well, right? So if I talk about, I have to process the image, right? So and at that point in time, it will take very less time these days when we want to, when we have to do the data processing of the images and so on. People are talking about self-driving car and various different things using artificial intelligence. So things are pretty much faster, and because of the processing power and also the data capacity of saving is increased as well. Because of that, the data science comes into picture. And now I'll talk about some of the real-time examples which I worked on. So I'm Rahul Tiwari with 14 years of industry experience, and I work for companies like Accenture, Capgemini, Tech Mahindra, and Deloitte. So I'm associated with Edureka for last 2 years. And if I talk about data science projects which I worked on, so when I was working for Deloitte, I worked on various different data science projects. And companies are taking data from various different data sources and trying to analyze that data, come up with the insights and so on. So uh, company wants basically. So there was one retail client who wanted to compare his own data with the competitors data as well and try to understand where he is lagging and what all things he's doing good. So all those things they will able to understand and try to plan the strategies. So these type of things they can do, and they can understand where they fall behind and how they can improve that particular section of the business. So that is what the need is, right? And data is there. And if I want to analyze the data, you will require a data science professional who can take care of that, understanding the data, do some predictions. For example, I want to know whether in the next month the goods sales will happen or not, maybe because of so many external factors. Like no one thought of having this type of lockdown for 2 3 months, and every business is stopped. And if I want to know what will be my revenue next year same time, obviously I have to consider these lockdowns as well which is going on. And because of that, obviously my overall revenue will decrease, because let's say I'm into teaching, then maybe they don't want to spend money on teaching because they don't know whether they will have their spending or not, right? Or they will get the salary or not, so they are not sure whether they can spend some money on the learning or not. Or maybe let's say some people are losing the job, so at that point in time they may want to spend some money on learning, right? So that can be a positive thing as well. So it depends on the scenario to scenario basis, that whether students would love to learn during this lockdown as they have a lot of time and they want to enhance the skill, or maybe they don't want to, they want to save money for the future months. So that is also can be happen. Now once that is done, now what is data science? Now, data science, known as data-driven science, makes use of scientific methods, processes, algorithms, and systems. So I'll take some example. I'll talk about some examples, then it will make more sense. For example, let's say I want to predict your salary based on your experience and your education and maybe your past companies you worked for. So based on that, I want to do some predictions. So I can very well do that, right? So that is one way of data science problem. So when I want to predict a continuous variable, for example salary, or let's say uh, YouTube likes, let's say I have my YouTube channel and I want to increase the likes and I want to know how many subscribers I will get in the next month. I'm predicting something, right? So when I'm predicting a continuous number, here I'm predicting a continuous number. So in that case I can say that yes, it is a regression, I would say regression type of machine learning problem. So let's say I will get a disease or not, right? So that is one of the, I would say, problem which I want to solve, whether my house will sell or not, yes or no, whether rain will happen or not, yes or no, right? So when we have a problem where I want to solve and want to know whether it is going to happen or not, in that case it's a classification. I want to classify, right? I want to classify whether the cricket will happen or not based on the weather conditions. So these type of things we can do using classification machine learning technique. So both regression and classification comes under supervised way of. So when we have, if you see here, extract the insights and the goal to discover hidden patterns from the raw data. That is what data science is all about, right? Data science is not only prediction, but yes, analyzing the data as well. So data science is like a big umbrella where I want to analyze the data. I have to come up with the insights from the existing data, or maybe I can, let's say, do some predictions and come up with the insights from that, like forecasted values, whether this will happen or not, or what is the next month revenue, or so on. So these type of things comes under data science. So it's like a full analyzing the data. At the same time, it's like a predicting the data using the statistical techniques, mathematical techniques, and it's like collection of everything is one big umbrella, which is nothing but data science, which includes artificial intelligence, which includes, what do you say, machine learning, deep learning, and so on. We have a lot of data for past, and then someone can claim that we had a data science, we had a machine learning, why we were not able to understand that corona will happen, right? We had a lot much raw data. All the things are going on. In China, people are talking about bats and doing all the analysis, right? So in that case, why we are not able to predict that this will happen? So some questions we cannot answer, but yes, people are doing a lot of research and they are able to find something and they are doing a lot of things, right? So it's up to feasibility as well, how feasible it is to actually apply data science on the data set. Now, let's go to the next slide. Life cycle of a data science is basically discovery, data preparation, data model planning, model building, then operationalize and communicate the results. So these are like basic type of flow chart which we have, right? First of all, I have to discover the problem, what business is actually looking for. After that, we'll do some data preparation, and then we have to decide which model to go for, which model will be the best model here, which variables are important for me to create the model, all those analysis. This entire part, right? Discovery, data preparation, and model planning. This entire part actually takes around 70 to 80% of the time. That is the main, I would say, steps which we have to perform. After that, this is like quick enough. These three steps are quick enough, but these three are actually you have to spend a lot of time. Now, these are the different types of languages which can be used for data science and data exploration or data analysis type of problems, right? If I talk about SQL, if you are getting into data world, SQL is pretty much required. There is no excuse. We cannot leave SQL aside because it is very, very important. Next is R programming and Python programming and SAS. These are the three softwares which we use for doing all the predictive type of analytics. Now here SAS is a cost. It's a licensed software. That's why people are now moving towards R and Python. And if I talk about Python, it's a amazing software, amazing programming language because we can do artificial intelligence, deep learning, machine learning, a lot of stuff. I can create the websites. I can uh, have the I can create the applications. I can do some automations using Python, and a lot of things can be done, right? So these are the three software. MATLAB also we can achieve that, but in industry point of view, I think Python is very much in demand and people are doing it a lot. Now Python, why people are using it? Because it's very easy to learn. This language is like a English type of language, and anyone can learn Python. That is what I can say. That is the main benefit of this particular language. I'll show some of the use cases. I'll try to implement some of the use cases. You will able to understand that yes, it is really very easy, right? So you will see that. Secondly, for data science point of view, statistics is very much important. At least some knowledge of statistics is really required, right? So if you are not very much liking the stats and maths, then you have to uh, take step back from this field. But if you are very much passionate about mathematics and statistics, then I think it's a big ocean. You can dig down and learn all these things. Very much required and very much interesting it is. So a lot of things you can explore and a lot of things you have to learn while you are getting into this field because it's like a never-ending process. Every time the new technologies will come in, new skill sets will come in, new algorithms will come in, so you have to understand the mathematics behind it, and it's like a never ending process. So if you're getting into data world, either it is data analyst or data science or any data engineer, you have to be up to your toes and you have to understand what all things are going on, and you should be very much uh, motivated to learn the new skills. Now, Python for data science. Now, it's simple and easy to learn. People say Python is like an amazing language and very simple to learn. Why it is simple to learn? Why people say that? Because if I talk about Java, right? I want to create a variable. Let's say I want to create a variable a is equal to 10. Now, a is what? A is a variable where I am saving the value as 10, and 10 is nothing but an integer, right? So I want to save an integer. So if I want to create a variable or I want to declare a variable in Java, it takes around 5 to 6 lines of a code. However, if I talk about Python, I just have to write 3 or 4 characters. I'll just show you that how to create the variable in Python. I want to create what? I want to create a variable a with value as 10. Done. Now I can see that a variable a is created with 10, and if I check the type is an integer. I don't have to declare as well. Python is a dynamically typed language. It automatically understands with the data which you are passing. Let's say if I am passing 10.0, and if I check the type, you can see that it is a float. That means it is a decimal. So it's a dynamically typed language, and you will be able to understand that how easily I'm able to create a variable in Python. That is the main benefit of this particular programming language. Second is fit for many platforms. You can run Python codes in C, Java. You can run Java codes, C codes in Python. All those things can be done. How flexible it is. Because Python is a language which is created by various different languages. So it has a flexibility to connect to any different languages and do the integration. So that is the main benefit of this program. It is high level and interpreted language. High level means human will able to understand. Human, like for example, some program which is coming in binary. So binary numbers will not able to understand 0100. What is that? Not sure. 1001. Not sure what's that. So it's a high level and interpreted language, which means that human can easily able to understand that what's going on and where is the problem and how to write the code. So that is the main thing of this particular programming language. Fourth one is perform data manipulation, analysis, and visualizations. I can perform analysis, I can create charts using Python, I can do data manipulations using Python as well. Powerful libraries for machine learning applications and other scientific computations, right? So it has a lot of powerful libraries. People say that Python has a lot of batteries inside it, right? So these are like batteries. The libraries are batteries. If you are looking for something, put the battery, done. You don't have to write a big line of code. NumPy and Pandas, these are the two libraries. I would say these are the two batteries for doing all the mathematical problems, right? Now NumPy is numerical Python. If I want to do any numerical type of problems, for example, let's say I want to take a square root of a number, right? Simple. I can do using NumPy. I don't have to write a code and all those things. I have a NumPy package. I can very well do that. I want to do some matrix calculation. I can do that using NumPy. Pandas is like when I want to get the data from outside. Suppose I have an Excel file and I want to put that Excel file in my Python instance. I can do that. All right. So these type of things we can do using these two packages, which we will see in some time. NumPy is a Python package which stands for numerical Python. Conda install NumPy, import NumPy. So these are like, first of all, you have to install in your current instance of Anaconda, and after that you can import NumPy so that it will be available in the current instance of Jupyter Notebook. Pandas is built on top of NumPy. It is used for data manipulation and analysis. Panda install Pandas, import Pandas. Okay, so let's go ahead and have some hands-on. We'll able to understand what is this all about. So my NumPy package is already present in the current instance of Anaconda. If you want, we can check that by going to Anaconda prompt. And from here, I can write pip list. And you can check that we have a list of packages which are available. It will come up in some time. And you can see that here I will have the packages NumPy as well as Pandas. If I go to the P, you can see that I will find Pandas somewhere. So here we go. Here is Pandas. Similarly, NumPy, you will find NumPy as well here. And this is the version number of the package. What is the version number? Now, this is already present in my current instance. Anaconda is a distribution system which you can download from anaconda.com. Once you download anaconda.com, like from anaconda.com, if you go to product, individual edition. Why we need Anaconda? Because Anaconda is like it's a good platform for data science. You can directly go and install Python from Python website as well. But the packages like NumPy, Pandas, Seaborn, these are the packages which by default comes with Anaconda, which you have to install manually in Python from Python website, right? So I prefer to go with Anaconda because these are the packages: Pandas, Scikit-learn, NumPy, Bouquet, Number, TensorFlow. All these comes by default in Anaconda. So you can go to this link. Based on your machine, you can go and install your Anaconda Python. So here you can have Python 3.7 version, which you can go for. And this is the link which you can use for installing in your machine. Once you install that, you go to Anaconda prompt and you can see that the packages by default comes in. I did not install it by myself, right? It automatically comes in with my current instance of Anaconda. Once that is done, my package is already present in my current instance. Now here I will just import Pandas as PD. I'm giving this as an alias and import NumPy as NP, which is nothing but NumPy package. Apart from that, what else? Now, let's say I have a list. I have a list of values. List one, which consists of some numbers. Okay. Let's say I give this as a sales. I'll just help you understand the benefit of NumPy package. And we have profit, which consists of some values. Okay, so I have 4 months of sales and 4 months of profit. Now what I'm looking for is I want the profit ratio. That means 54 divided by 324, 34 divided by 556, 35 divided by 443, and 66 divided by 345. Now for that, what will I do? Maybe I will try profit divided by sales. It will throw me an error. I cannot able to show you how we can integrate the website with Jupyter Notebook because I don't have any server where I can host that. But it is possible. People are doing it. So if you have server, you can try from your side. List by list is not possible. Profit divided by sales is not possible because I cannot divide a list by a list. So what is the solution? Let's go with a for loop, right? So I'll create a for loop which will help me divide profit by sales. So I have a profit ratio, which is an empty list. All right, and then for I in range 0 comma length of sales, profit ratio dot append profit of I divided by sales of I, and profit ratio is my final outcome. Here we go. It's output, right? So here I am able to do the division, which is nothing but 54 divided by 324, 34 divided by 556, 35 divided by 443, and 66 divided by 345. So it is iterating. For loop is nothing but it is iterating one value from second value from second value, third value divided by third value, fourth value divided by fourth value. So basically, when I want to iterate on multiple lists or on a single list, I can apply a for loop for I in, right? So for example, let's say I have a list 1, 1, 2, 3, 4, 5, and then I want to print this values. So what will I do? I will write for I in list 1, right? Print of I. You'll see that it is printing the values because now I is going to iterate on list 1. List 1 is what? 1, 2, 3, 4, 5. So for I in list 1, print of I, right? So the first value of I will be 1, then 2, then 3, then 4, then 5. So it will print on and give me the output till 5. Now this is a tedious process because now it's what's happening here in this for loop. First value divided by first value, second value divided by second value, third value divided by third value, fourth value divided by fourth value. Okay, I cannot able to explain each and every command here. It is expected that if you are attending this session Python for data science, you have a basic idea what is length, what is for loop, right? So please try to explore from your side. Length is nothing but how many values we have. How many values? 1, 2, 3, 4, right? So length of sales will be 4. Then range function iterates from 0 to 4. So all those things you should aware of. Now here, it's like a row by row processing, right? Now row by row processing, I don't want. So what is the problem? What is the solution? The solution is NumPy. So let's say I'm creating sales array. Okay. NP is the package which we imported at the start, NumPy. So what I will do is I'll just write NP dot. I want to convert my sales list to an array. NP dot array, and I will have the sales list. And you can check that I have a sales array ready, which consists of the same values which we had in the list. Same way we have profit array is equal to np dot array, and we have profit execute. You will have profit array, and here we go. Now what I am looking for, I am looking for a profit ratio, which is nothing but profit divided by sales. Can I divide profit array by sales array? Yes, you can. And here is the output. You can see that now the answer which we are getting here is exactly same as what we are getting here as well. So you can see that this is looking perfect. Without writing any loop, we are able to solve the problem. So when I am running a for loop, it is a row by row processing. However, when I am running a NumPy array division, in that case at the back end, it runs a loop, and but it's gonna give me the output quickly. All right. Now, what else can be done? Well, let's say np dot square root, and let's say I want to find the square root of 100. So you can see that we are getting 10. All right. So a lot of mathematical functions are available in NumPy. If you see here, np dot and press tab, you can see all the values which we have. A lot of functions are available. So all the mathematical problems which you want to solve, NumPy is ready to use, and we can solve the problems using NumPy. Now, second is I want to use Pandas. Now, Pandas is a package which is helping me to import any data from external source to Python, right? So let's say I have a data source. Let's say this is my data source, which is nothing but a CSV file, comma separated value file. You see, I have total bill, tip, sex, smoker, day, time, and size. Okay. So I want to put this data in the current instance of Jupyter Notebook. So first of all, I will set this particular location as my working directory. So what I will do, I'll write import os.chdr change directory, and I'll pass the values, which is nothing but the location of my file. Execute. And then what I will do is, what is my file name? My file name is tips.csv. So pd.read csv, and I will write tips.csv, right? You can see that how beautifully you are able to get the data in the current instance of Python. So I used PD. PD is nothing but pandas, which we imported above, right? Pandas as PD. So here I imported the data here. We got the output, and let me save it in my current instance. So let's say tips is equal to, okay. Now I can see that we are getting the data, and we saved the data in a variable named as tips. Now when I open this tips, you can see that my data is there. Now, how many records we have? Length 244. OS is an operating system module which is helping me to change the directories or get the directories. I want to know what is my current working directory, os.getcwd, and you can check what is my current working directory. This is my current working directory where my files are present, or I can pick up the files from this locations. This the length of the tips means how many records I have, 244. Let's see in the CSV file. The total number of records I have is 244. Perfect. Next, tips.columns, and we have length. Let me pass it. You see we have 7 columns. That means I will have 7 columns, 1 2 3 4 5 6 7, right? That means total number of columns I have in my data set are 7. So this is how we are able to get the output. Next, now this is how we can import the data, and now we can play around with the data as well. R is for raw text. Here I have to put R as raw text because there are a lot of colons, slashes, and all, right? Now this slash is what? This slash is nothing but wildcard as well, if you have understanding of the regular expression package. So if I don't want to put R, then you have to put slash everywhere to help Python understand that this slash is nothing but my character in the path, right? So I have to pass the entire values with the double slashes. If you will pass R, then you don't require double slashes. Now I can play around with the data. Let's say I want to know first few records of my data set. So tips dot head is the command. It will give me top 5 records. If I go with tips dot tail, then it will give me bottom 5 records, right? Now, apart from head and tail, what else can be done? What else we will able to do? Let's say business comes to me and says that, can you please give me only total bill column, smoker column, and time column? The rest of the columns I am not interested in. Can you only pick these 3 columns? I can do that. So tips dot, or I can say tips double square bracket. First bill is total bill. First column is total bill. Second is smoker, which is my second column, which I'm interested in. And the third column, which I'm interested in, is time. Execute. You can see that here we go. We have the 3 columns which I'm interested in. So if you are looking for these columns which are there, you can very well able to do that. Why 2 bracket? Because that is the syntax. When we are looking for any particular column, we have to pass with a double square bracket. If you are not interested in double square bracket, then there is one more command called iloc, index location. So let's use index location. So we have tips dot iloc, which is index location. I'm interested in colon as of now. Colon means all rows, all columns. Now let's say I'm writing colon comma 236. Let's see what happens. I'm getting sex, smoker, and size. Why? Indexation in Python starts with 0, right? So we have tips. What is the index? What I wrote 236, right? 236. What is 2012? Sex. 3 smoker. 456 size, right? So you are getting sex, smoker, and size. Sex, smoker, and size. That is what we are getting. So when you are looking for any particular set of column, you can pass that in the square bracket. Suppose you are looking for consecutive columns: sex, smoker, day, time, and size. What will you do? Indexation of sex is 0, 1, 2. Starting with 2, what is the last index? 6. I will write 2 colon 7. So here in place of this square bracket, I'll just write 2 colon 7. Okay, you see that you'll get all the values. Now, what else can be done? We can apply, let's say business says that I want time equal to dinner. I want all the data where time is equal to dinner. Tips, square bracket, tips, which column? Time is equal to dinner. So I'll see all the data. I'm getting dinner, 176 rows. Okay, so total rows I'm getting is 176. Let's say I'll go with lunch. So I'll get all the lunch. 68 records are lunch. Business comes to me and says that, okay, I want one more filter on this data where time is equal to dinner, that I want, and tip is greater than 5. So I want to apply 2 filters, right? So tips tips. Now I'm looking for a conditions, right? So if you see here, tips, then we will have a square bracket, then tips time is equal to dinner, ampersand is for end, tips tip is greater than 5. So now you can see that I'm getting all the records. Total records I'm getting is only few, right? 1, 2, 3. I can count, or in place of that, I can just write length at the start. I'll see 15 records I am getting, where time is equal to dinner and tip is greater than 5. You see that all the tips are greater than 5 and time is equal to dinner. So I can apply this AND condition. Business says that I am looking for time equal to dinner or tip greater than 5. So it's like OR condition. In place of AND, I can go with OR. OR is nothing but the pipe character. So this pipe character means OR condition. So you're getting different output. The total number of records which you're getting is 179, right? So that is what the AND and OR conditions are. Now, apart from that, what else can be done? Let's say I want to know how many males and females are there. In my data set, there is a column called sex, which is gonna give me how many males and females are there. Let's say in my data set, we have this sex column, right? And I want to know that what is the count of male and female. So in that case, I can group by. I can group by the data and give the output. For example, let's say tips dot group by. On which column I want to group by? I want to do group by on the sex column. I want to know how many females and males are there. So sex and dot size. Okay. So now you can see that in my data set, total columns which we have is 87 female and 157 male. Now let's say I want to know how many smokers are there. Tips is nothing but the data frame which we have created. Here we created the data frame by importing the data set. I gave the name as tips. All the data is present in the tips now. So now here I want to group by. I want to know how many smokers are there, how many male smokers are there, how many female smokers are there, and how many male non-smokers are there, how many female non-smokers are there. How will I do that? Tips dot group by, and here I will write smoker comma sex dot size, right? You can see that you are getting the output, which is nothing but 54, 97, 33, 60. So smoker no, female, non-smoker female we have 54, non-smoker male we have 97, smoker female we have 33, and smoker male we have 60. And D is the data type, the integer 64. The data type which we are getting is integers, the counts. So that is how you'll able to play around with the pandas. It's just an understanding of pandas, what all things we can do using pandas. Now let's come back to the PPT again, and now we'll have a quick overview of the machine learning. Now, what is a machine learning? Machine learning is a type of artificial intelligence that allows software applications to learn from the data and become more accurate in predicting outcomes without human intervention. Training the data, learn algorithm, build the model, perform, and do the feedback. So basically, machine is automatically, I have to give the data for training. Machine will understand the data, come up with the insights, come up with the predictions, and as and when the new data will come in automatically, it will start learning by itself. So I have to keep passing the data to the machine so that machine will able to understand what's going on, and based on that it will decide the predicted value. There are three types of machine learning. We already had a brief idea about supervised machine learning, which consists of two type of techniques. First is regression. When I want to do the prediction of a continuous number, in that case we have a regression technique. But when I have a prediction of a discrete values, yes or no, then it is a classification problem. And these two things comes in a supervised way of machine learning. Because why it is known as supervised machine learning? Because let's say I see 150 plus audiences out here. Based on your experiences, I want to predict your salary, right? And I already know your salary because you guys are in my company. I'm the HR of the company and I know all of your salaries. But what I will do is I'll divide the data into test and train. Let's say I have 150 attendees, 150 employees. I will divide into 70% as train data, 30% as test data. So what I will do, around 100 records I will put in the train data, 50 records I will put that in the test data. Now what I will actually gonna do, I will perform my model building on the trained data, the 100 records, and then based on the existing data I will create a model. And as I already know the salary of the rest 50 records which are there in the test data, I can just pass the model which is trained in the trained data, I can pass that in the test data, and we'll try to understand what is the output I'm getting on test data by creating the model which was created on the trained data. So based on that, I'm creating the model on the trained data and testing in the test data. And I already know the actual salary of that 50 employees. I will able to compare that. If the error is less, that means good. We have the data set, like we have the correct output. If the error is more, then I have to think again that why the error is coming more. What else can we do, right, to improve the model performance? So that is why it is known as supervised machine learning. We get the data from business and we have a package called Scikit-learn which helps me to break the data into test and train. The second way of machine learning is unsupervised way of machine learning. For example, let's say I want to cluster you guys, right? I see a lot of questions which are like basics of Python questions. I see questions which are like advanced type of questions. So I can very well, based on the type of questions you are asking, I can cluster the audiences, some who are new to Python, some who are intermediate to Python, some who are advanced in Python, right? So I'm clustering the participants. So here clustering is helping me to segregate my data, right? So that I will able to use that more efficiently. For example, my marketing budget is very less. I cannot email to all 150 attendees, right? Because that is a cost for me. So in that case, what will I do? Obviously, when I'm launching a Python basic course, I will email to those guys as per my cluster that these guys are the new to Python. So when I'm running an unsupervised way of machine learning, based on the behavior, it segregates the data. All right. So that creates a different type of clusters. People with no Python knowledge, people with average Python knowledge, people with advanced Python knowledge. I segregated the data and then I will start doing the session marketing to those guys. Let's say I'm coming with the basics of Python course. So I will target those guys who don't know Python or new to Python. So that is what unsupervised learning is all about. I cannot test that whether it is correct or not because it is purely based on the data set. There are chances that some of you guys are very much advanced in Python, but they want to know my skill set, whether I know or not. That's why you are asking the question. So that is possible, right? But I will cluster you guys that you don't know Python. So purely based on the data set, I'm just segregating the data, and that is what we are using. Is unsupervised way of machine learning. The third way of machine learning is reinforcement learning. Right. So in the reinforcement learning, we have again one step ahead of the normal machine learning algorithms. I can say it's one step towards artificial intelligence. These are the various algorithms which we have, right? So for supervised machine learning, we have algorithms like linear regression, logistic regression, decision tree, random forest, naive bayes classifier. These are the different types of algorithms which we have. There are a lot of mathematics and statistics behind it. I'll take one example of logistic regression in some time. But before that, let me check what all PPT we have. We'll discuss that and then we'll come to practical example. Logistic regression produces result in a binary format, whether this will happen or not. Yes or no type of scenarios, logistic regression comes into picture. Used to predict outcome of a categorical dependent variable. Outputs can be yes, no, true, false, high, low, pass, fail. This type of output we get. Relation between dependent and independent variable. So unknown value of a variable or the variable to be predicted is my dependent variable. Independent is like a known variable or the variable related to dependent variable, right? I want to predict something which is dependent using independent variables, where y is the intercept and here ax plus b, it's a tangent angle made by the line. Now, second is unsupervised way of machine learning, which is clustering the data, right? I'm clustering the data. Unsupervised learning is a training of a model using information that is neither classified or labeled. I told you earlier that it's not a labeled data. It is purely based on the data which I have, right? Which I have. And based on that, I want to just cluster and create a different groups. Unsupervised learning is called as clustering analysis. K means clustering and hierarchy clustering are the two main types of algorithms which we have. Reinforcement learning, it is an area of machine learning where reinforcement agent learns from the consequences of its actions rather than from being taught explicitly. It selects its actions on basis of its past experiences, exploitation, and also by new choices, exploration. There are algorithms like Q-learning, SARSA, and DQN. Q-learning is very much in demand. People are using that. Now, let's take one example where we'll apply the logistic regression. I'll take one data set to try to solve one logistic regression problem. So here is my data, and from this data what I'm looking for is I want to predict whether my customer will purchase the product or not based on, let's say, age and estimated salary. So based on age and estimated salary, I want to predict whether he will purchase the product or not. All right, so these are the two columns which are my independent variable and this is my dependent variable. So I'll import this data set from this location because this location is my working directory where the file is present. So I'll go ahead and pd.read csv. Now, if you don't want to set the working directory, you can directly give the file name with the path name. That is also possible. .csv, and I'll give this in the bracket. You can see the data is coming in. Let me put the name as df data frame. So my data is now imported, named as df, and let me put it here, df execute. Here is my data set. Now, based on age and estimated salary, I want to predict the purchase. So what I'll do, I'll split the data into x and y. I'll make this as x and this as y. We already understood the iLog function. Index number 0, 1, 2 and 3. Index number 2 and 3 is what my x is, right? So df.ilog, I'll make colon comma 2 colon 4. Execute, you will get age and estimated salary. You can put anything apart from df, you can give anything. There is nothing like name it. Like I prefer what's a data frame, I made it as df. You can give your hr also, anything, no issues. Dot values, and here we go. This is my x. Okay, dot values is converting the data frame to array. So here I have an array which consists of my estimated salary and age. After that, we want to split the data into y. Y is nothing but the last column. So df is my column. Here purchase is the last column. So 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Fourth column is my purchase. So df dot ilog colon comma 4. If I will execute, you see I'm getting the values. Dot values is my y. So I have y, I have x, both are ready. Once I split the data into x and y, now what I'm looking for, I'm looking for my data is perfectly fine. What I'm looking for is I want to split the data into test and train. So for that, there is a package called Scikit-learn. For any machine learning algorithm, this is the amazing package which we have. You can see machine learning in Python. Scikit-learn is a package which we use for machine learning in Python. So from sklearn, which is nothing but scikit-learn, import model selection from scikit-learn dot model selection, import train test split. So from scikit-learn dot model selection, import train test split. After that, what we will do? X train, X test, Y train, Y test is equal to train test split X comma Y test size is equal to 0.25, let's say. Okay. So now what I did is I split the data into test and train. I gave 75% to train data and 25% to test it. Okay, so as per the industry standard, people can use 70-30, 80-20, 15-85, 25-75, and so on. We normally don't prefer to go with 50-50. We prefer to go bit of more towards train and give some less data to test. So now if you see here, how many records I had in my X? I had total length, if I'll check, I think it has 200 records, something. 400. So I have 400 records in my X. So around 75% record means 300. So let's check how much I have in X train. In X train we have 300 records, and in X test we have 100 records. Okay. So I divided the data properly. Same way Y also. Y train should have 300 records and Y test should have 100 records. Perfect. So I split the data into test and train. Now what I want is I want to create a model on the trained data and then test on the test data. And that is what my requirement is. So let's say I'm applying from sklearn. Now it's time for creating the model from sklearn. Linear model, import logistic regression. Log model is equal to logistic regression, xtrain, sorry, I'll write directly logistic regression, log model dot fit, xtrain, ytrain. I trained the model, right? On the trained data set, I applied log model, which is nothing but logistic regression. After that, once my model is created, log model dot predict. I want to predict my X test data. And as per my test data, I am getting all as zeros. That means no one is purchasing the product because zero means no one, one means purchasing. So as per my model, no one is purchasing the product. But what is the actual output? Well, I already know why test, right? So here there are some people who are purchasing the product. However, in the predicted value, no one is purchasing the product. So looks like the model is not giving me good accuracy. Or I can say model is not predicting the correct values. So I can apply different algorithms as well. But as of now, how to find the accuracy of a model, I'll just talk about that. And then I'll apply one more algorithm, maybe k nearest neighbor, and try to see what outcome we are getting there. So here we have, let's say, ypred is equal to. So I have this ypred, which I want to compare with x test, right? Because this is my actual value, this is my predicted value. So here we have 0, here 0. That means my prediction is correct. But here we have 1, here we have 0. That means the prediction is wrong. So in that case, we have to check the accuracy. So for that, we have a concept of confusion matrix. From sklearn dot matrices, import confusion matrix. Confusion matrix is helping me to get the accuracy of a model. So confusion matrix, and then I'll pass the values. y test, y pred, and you are getting some numbers out here, right? 58 0, 42 0. As of now, I'm not explaining this. I'll explain that once I apply one more model. Let me apply second model. Now we can apply different models. So let me apply one more model, k nearest neighbor, and then this confusion matrix I will compare with that confusion matrix, and you will be able to understand it in detail. So from sklearn, I'm applying now next algorithm because logistic regression is not giving me good accuracy. Looks like that. We'll check that. I'll apply one more model from sklearn.neighbors, import k neighbor classifier. It's a classification problem, right? Yes or no. So k neighbors classifier is equal to knn, n neighbors is equal to 5. The default number which we have for n neighbors are 5, because n neighbors is nothing but it is actually trying to see the nearest people, and let's say whether Lokesh will purchase the product or not. My algorithm will find the 5 nearest people from Lokesh. Out of 5, how many are purchasing, how many are not purchasing? Suppose 3 are purchasing, 2 are not purchasing. That means the chances of Lokesh to purchase the product is more, because the majority is more there, right? So that is the idea of k nearest neighbor. Classifier dot fit x train y train. Okay, I applied the model. Classifier dot predict x test, and we are getting some ones as well. Now this looks good. Let's check the accuracy. So let me save this as y pred knn is equal to some value, confusion matrix y test y pred knn, and I'm getting some numbers. Now this number and this number are different. Now this is very important to understand. Let's try to understand that. So we have logistic regression. I have two values out here, 0 1 0 1, and I'll just write one more line, plus 0 1. This is my thread, this is my actual, and I'm getting some numbers here, right? 58 0, 42 0. So 58 0, 42 0. For k nearest neighbor, what we are getting, the numbers we are getting is 50 26, 50 26, 816, 816. These are the numbers I'm getting. Now let's try to understand what it is all about. Now this is my value for logistic regression. This is my value for k nearest neighbor. First of all, this coming from where? This coming from the test data. How many test data we had? If you guys remember, length of x test, how many we had? 100. Can you see that some of these two values are 100? Some of these four values are 100. Perfect. Now, if I will count, if I go to my y test, this is the value we have, actual value, actual answers. If I will sum, how much I am getting? 42. Y test, that means if I'll sum all the ones, that means there are 42 people who are purchasing the product. Can I say that? Now here, can you see that 42? Can you see that summing up this also I'm getting 42? So basically, when I am reading row wise, it means that it is the actual value. As per the actual data, 58 people are not purchasing the product. As per the actual data, 42 people are purchasing the product. As per the actual data, 58 people are not purchasing the product. As per the actual data, 42 people are purchasing the product. But when I read column wise, 100 people are not purchasing the product. When you see in the log model, right, ypred, in ypred I am getting all zeros because no one is purchasing the product. So here 100 people are not purchasing the product, 0 people are purchasing the product. If I'll see here in my ypred knn, and if I will sum this, what will I get? I will get 24. What does that mean? 16 plus 8, 24 people are purchasing the product as per my model, and 50 plus 26, 76 people are not purchasing. So basically when I am reading row wise, that is my actual data. When I am reading column wise, that is my predicted data. And as per my model and actual, 0 0, 58 people are purchasing, not purchasing the product, right? 0 as per the actual, 0 as per the predicted. How many are common? 58. 1 as per the actual, 1 as per the predicted. How many are common? 0. So what is the accuracy of a model? 58 plus 0 divided by all. So my model accuracy comes out to be 58 by 100. That is nothing but my model accuracy when I am using logistic regression coming out to be 58%. However, when I see here, how many are correct? 50 and 16. That is 66. So my model percentage coming out to be 68, 66% accuracy, because as per the model and actual data, 50 are not purchasing the product. As per the model and actual data, 16 are purchasing the product. The common comes out to be 50 plus 16, that is nothing but 66. Model accuracy is 66%. So which one is better? K nearest neighbor looks better. And that is how you will able to apply the classification technique. There are 6-7 algorithms which you can run, right? We only spoke about 2. K nearest neighbor is nothing but, suppose I am creating this as a scatter plot. I'll just quickly talk about it. K nearest neighbor, what it does is, let's say I want to know whether this customer will purchase the product or not. It will find the nearest neighbor, 1, 2, 3, 4, 5. Let's say 5 people. These are the 5 people. Okay, let me just put that in the paint. Okay, so let's say I want to know whether this guy will purchase the product or not. It will find the distance. It will find the distance between nearest 5 neighbors. Let's say this is near, this is near, this is near, this is near, and this is near. Okay, 5 nearest neighbors. Out of that, these 2 guys are not purchasing the product. These 3 guys are purchasing the product. So out of 5, how many are purchasing? 3. How many not purchasing? 2. Can I say that 60% chances are there that this person will purchase the product? 40% chances are there this person will not purchase the product because of the ratio? So that is what the K nearest neighbor is all about. Okay. So that is how we solve this problem. Different type of algorithms which we have are, I'll just list that out. So the different type of algorithms which we have for classification is, first is logistic, which we already discussed. Second is KNN, K nearest neighbor. Then we have naive Bayes. Then we have decision tree. Then we have random forest. Then we have support vector machine. Okay, these are the 6 algorithms people are using it for classification. So that is what the machine learning is all about. We solve this problem easily and able to get the predictions. So this is what I have to discuss in this entire session. Thank you for your time. Stay safe and bye bye.